All right, so let's take a look at velocity time graphs. So an object's velocity time graph shows a lot of information. We're going to examine this graph and we're going to describe the motion or what's going on in each section. So we're going to do the same thing for this graph that we did for the position time graph. So the first thing we need to look at with this velocity time graph is we need to look at these two areas where we have a slope of 0. So this object is stationary. This is what we need to look at though. So if we're in a velocity time graph, so for a velocity time graph, this across line doesn't mean stationary. So this 0 doesn't mean stationary. It just means that the velocity is constant. So velocity time graph, a horizontal line means constant velocity. The reason the object is stationary right here is because we're at 0 meters per second at the point of origin. So they're at the point of origin and they're not going anywhere. The velocity is 0. So the velocity here is 0 meters per second. The same thing is happening here. So we're stationary and our velocity is equal to 0 meters per second here as well. So let's apply this somewhere else on the graph and let's look at the very top of the graph. The very top of the graph right here also has a horizontal line. So that horizontal line means constant velocity. So the velocity right here is constant, but what do we know about this velocity? This velocity is at 20 meters per second north. So there's a constant velocity at 20 meters per second. Our slope here, though, is 0 meters per second squared. So that 0 slope shows us that the object isn't accelerating. All right. So the next part of the graph we're going to look at, or the next piece of the graph Miss Neal comes to, I've dealt with all my horizontal lines, dealt with all my slope as being 0. I'm going to look at this right here. All right. So right there, the object is accelerating, right? The velocity is getting bigger and bigger and bigger. So my object is accelerating. And it's accelerating north. We know this because the slope is positive. So the slope right here is positive. So we know that it's accelerating north. It's speeding up. So to figure out slope, if we need a refresher, the acceleration is equal to the slope for here. And the acceleration is equal to final velocity minus initial velocity over final time minus initial time. So on a velocity time graph, that slope is acceleration. So slope is acceleration. All right. This is the next piece I come to. And I'm going to use orange again because I don't have yellow. Yellow wouldn't show up. So we have a negative slope. Or acceleration south. So what does that mean exactly? That means we're slowing down. All right. Now we're back in the bottom of the graph. So we've crossed over this x-axis, right? So up here, the velocity is positive. Down here, the velocity is negative. So if this up here is north, everything down here at the bottom of the graph is going to be south. So all of this is south. Okay, so speed is increasing. The speed is getting faster and faster and faster and faster. That velocity is increasing. So we know we are accelerating. But we're not accelerating north. We're accelerating south. Or in the negative direction. We again have a negative slope. But when that negative slope is below the x-axis, it just means we're accelerating in the southward direction. So speed is increasing. And if that confuses you, you can always read the graph. So if we look at the graph, right here, we're at 0 meters per second squared. Right here, our velocity is 5 meters per second squared. If we come all the way up here, our velocity is 20 meters per second squared. So we definitely sped up right there. We got faster. If we look over here, our velocity is 20 meters per second squared. Again, right here, it's 5 meters per second squared. And it's 0 meters per second squared when we reach the axis. So 20 going to 5, that's slowing down. All right. If we come down here beneath the line, we're at negative 5 meters per second squared. If we look right here, we're at negative 20 meters per second squared. So 20 is faster than 5. All the negative means down here is that we're south. We're heading in the opposite direction. All right, so I want to do the same thing as I did last time with Red Riding Hood. So we're going to write a story that matches this velocity time graph. All right, so number 1 is position 1. So number 1, how many seconds do we have? 1, 2. So for 2 seconds, Pig and Red Riding Hood wait in Pig's car. 2. So 2 is what's going on right here. Pig presses the gas. And the car accelerates over, how long did it accelerate? 2 seconds, to a velocity top speed of 20 meters per second. Three. The car, so 3 is right here, travels at a constant velocity of, we're at 20 meters per second. We're north for 2 seconds. Four. Pig sees his brother in the stick house. And he knows the wolf is going to be after him. So Pig slows down from 20 meters per second to 0 meters per second as he pulls over and stops. And how long did it take Pig to reach that stop? 2 seconds. So this takes 2 seconds. Five. The car is stationary for 1 second. Pig sees wolf in the rear view and goes another way. Because clearly wolf knows where he's heading and he doesn't want to head that way. He needs to go a different way. So last but not least, Pig accelerates the car south from 0 meters per second to 20 meters per second over 3 seconds. So Pig makes a U-turn. He going back south. All right, if you have any questions or comments about the velocity time graph, please feel free to shoot me an email.